do have notes today. Your notes and your homework are in the same sheet. Okay, so it's all together, so you don't have to worry about the book and stuff like that, because I know that some of us have lost our books or tossed our books or whatever. So today we're going to talk about, and for this week we're going to talk about probability. You will have a quiz over probability on Monday. Okay, I won't be here. I have a doctor's appointment, so I figured let's just quiz on Monday, because then you won't miss any instruction, right? So we're going to talk about this week about probability. So probability is the likelihood that an event will occur. Okay. So you either have a 100% chance of something happening, or you have 0% chance of happening, and then you have a scale in between. So if something has 0% chance of happening, we call that impossible, right? Okay. If something has a 100% chance of happening, we call that certain. Okay. What if something has a 50-50 chance? No. Is it going to occur?
Maybe. We don't know.
Is it not going to occur?
No.
Maybe, maybe not, right? We don't know. It's 50-50, right? It's 50% chance of happening. When we say something is a 50% chance of happening, we call that, again, it's a 50% chance. Okay? It's just as likely as it's going to happen as it is unlikely as it's going to happen, or it is going to happen. Bear with me, right? So when we're talking about probability, we're also going to be talking about outcomes. Okay? So the outcomes are the possible results of an event. Okay? So for example, number one, understanding the outcomes of an event and the probability of an event. So we're going to work with some manipulatives today, okay? I'm going to work with them because I can't give them to you and then clean them, because like we're going to work with a deck of cards, and we're going to be working with like red yellow chips or positive negative chips and dice. So just because I can't give you those, which I would typically give them to you, what I did, oh, that was a really good catch. So in your Google Classrooms, under classwork, I have probability tools. Okay? So if you need like this for homework, or if you need it for like to help you review, if I give you something to do and you don't actually have cards or a dice or a coin at home, I've got these here for you. Okay, so if you roll a dice, this is just actually a YouTube, and you stop it. Okay, so that's a 4. Roll it again, it's a 6, right? So that gives you a simulation for probability. So that's your roll of dice. And then this one, flip a coin. I use a red yellow chip. Same thing, right? Okay, so again, it just simulates flipping a coin for you. And then the last one here is a random card picker. Pick a card, any card. Okay, 5 of clubs. Two of hearts. Okay, so it simulates what you need, right? Cool? Okay, so those are there if you need to do a simulation, or if you need, if on homework it asks you to model the event. So those are there for you. And again, that is in this week's Google Classroom, right here. Okay. Questions? Okay. All right, so let's go ahead and look here. Understanding the outcomes of an event. So if we look at our red, yellow chip here, what are the possible outcomes?
Red and yellow.
Red and yellow, right? So those are our possible outcomes. We can flip a red, or we can flip a yellow. Standard number cube. 1, 2, 3, 4, 5, 6, right? Are there different number cubes? Who plays D&D? Anyone play Dungeons and Dragons? Right? Is it 12-sided in Dungeons and Dragons, right? And what else? What's another?
Yeah,
There's a ton of them. I didn't know that until a couple years ago. I've never played that, but it's always good to learn new things. Okay, so those are our possible outcomes for our number cube. Okay, so how many possible outcomes are there for our red yellow chip?
2.
And then there are 6 possible outcomes for a number cube. What about a deck of cards? Okay, there's 52 different outcomes, right? Okay, so there's 52 possible outcomes. Okay, but there can also be something else. You can either pick a red or a black. So then there could be how many possible outcomes? 2. Right? Okay. 52 possible. Well, these are each unique cards. And when I say a unique card, I mean like I have one chance of pulling an 8 of clubs out. I have one chance of pulling a 5 of clubs out. I have one chance pulling a 3 of diamonds out. So when I say unique, okay, so there's 52 possible outcomes if it's unique. Okay? A deck of cards, what else could there be?
4.
4, why?
Because of the classes.
Okay, the suits, very good. Okay, so then there's 4 possible outcomes as well. Okay, and that's our suits. Okay, so diamond, heart, spade, and club. Yes, dear.
I don't have a pencil anymore. I ran out of it.
Okay, are there pencils in the back? Yes, dear. What? 3 for what?
King, queen, or jack.
Okay, that would be face cards, so we could use that. But then, you've got 3 face cards, Jack, Jack, King, Queen, Ace, right? We'll call those 4. But then so that's 4, and there's 4 suits. So that kind of doesn't work for us. 13. Does that work?
Yeah,
Why?
Numbers.
because 1 through king. Oh, that's
2 through ace?
yeah, 2 through 8.
Okay, so the deck of cards is really versatile, right? Okay, it is very versatile. I can't write all the possible outcomes out. I just can't. I mean, I could, but I'm not going to. I'm not going to waste our time, correct? So there are lots of different outcomes that can happen with our different red, yellow chip, number cube, and then a deck of cards. The deck of cards is the most versatile as long as you have all 52 of them, right? Okay. All right. We play cards at our house all the time. We play a game called 31. And you get 3 coins. You know what I'm talking about? 3 coins, you try to get the closest to 31. And so, without going over.
I thought it was
and like you have to add, it has to have the same suit, or you can have 3 aces and get 31. So Lucy loves it. It's a really good math game for Lucy, you know, because she's in 1st grade and it's, you know, adding double digit, you know, and single digit numbers. So we play it. We play cards all the time. Her current favorite though is Clue. She loves Clue. So, and she really likes to cheat when she plays Clue. She's always like, I was like, did Uncle Nick teach you how to play? She goes, absolutely. My brother-in-law is the biggest Clue cheater ever. So, yep. But she always has to be Miss Scarlet. That's her favorite character.
I like mustard.
What?
I like the mustard.
You like mustard? I don't really care. I just sit wherever and play. All right. So the next thing we're gonna yell at. Next thing we're gonna talk about is probability of an event. Now, when we're calculating probability, we're finding the ratio of favorable outcomes to total number of outcomes. So the way we set it up is P of an event is equal to favorable outcomes over total outcomes. Okay, so favorable outcomes, that's what you want to happen, right?
Yeah.
So again, that's what we want to happen over the total possible outcomes. So let's think about our red yellow chip. Okay? So what is the probability of flipping a red?
50%.
Okay, so 50%. So if I am writing this out to model probability of flipping a red, okay, so this is the probability of the event happening. So your event goes in the parentheses. And again, it's the ratio of favorable outcomes to total number of outcomes. So how many outcomes are there when I flip a red yellow chip or a coin? There's 2. So the total number of outcomes is 2. And the favorable, how many ways can I get a red? Only 1. Now, we could say 1/2. We can also say 50%. Does it matter which one we use? No, because they're all equivalent, right? All right, so what about my number cube? Okay, so we know how many possible outcomes are there.
6.
Very good. But I want to know the probability of rolling an even. So my total number of outcomes is 6. Okay, now on my number cube, it's 1, 2, 3, 4, 5, 6. An even number ends in a 2, 4, 6, or 0, right? Or 8. 8 or 0. But on my number cube, I've got 1. Is that a favorable outcome?
No.
What about 2?
Yes.
3,
No.
4,
Yes.
5,
No.
6?
Yes.
Okay. So that is
3.
3 out of 6. Would I leave it as 3 out of 6? We could make it a half. So we can reduce it. So you can reduce it down to half. Or 50%. What about the next one? Okay, so let's think about it. Okay, don't say anything yet. you've got 4 suits. Hearts, diamonds, spades, clubs. Each one of those suits has a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, and ace. Because there's 13, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9, jack, queen, king, ace. There's 12?
I forgot
10. 10. Oh my gosh. I told you. It's getting rough. Everything's going here, not here. So there's 13 in a suit, and there's 4 suits. So 13 times 4 is 52. That's where you get the number of decks in a card, or the number of cards in a deck. Okay? How many of those cards are actually queens? 4. Okay? So when the probability of drawing a queen, favorable would be 4. Queen of hearts, queen of diamonds, queen of spades, queen of clubs. And altogether, there's 52 cards in our deck. And 4 to 52 actually reduces down to 113. And I don't know, well, yeah, I don't know what percent that is. I don't know that one off the top of my head. It's gotta be lower than 10, right?
Yeah.
So it's about 8%. Okay. So if I do this, and I ask Shane to pick a card out of the deck, what's the probability that he's going to draw a queen?
8%.
8%. Right? So is he likely to draw a queen?
No.
No. He's got to be at about 75% or higher to make that likely, right? We're super unlikely to draw a queen if we fan out the cards, right? Okay. What about, what's our likelihood going to be of drawing a black? 50%, right? So that's way higher. What do we get? Oh, see. Okay. These are not shuffled. I have no idea. I literally pulled them out of the drawer this morning. So. Any questions so far on probability? When do we use probability? Never? Weather, okay.
Chances.
Huh?
Chances.
Chances.
Betting.
Betting. Huh?
Gambling in general.
Gambling in general. Okay. What just ended yesterday?
Marksman.
Okay. NCAA basketball tournament, right? Women's ended on Friday or on Sunday. Men's ended last night. Probability? Absolutely probability. A team goes into the tournament with a 1 in 64 chance of winning. Okay? There's 64 teams, right? Or 64, yeah, 64 teams. Okay?
16 in each.
Yeah. So 64, you have 1 in 64 chance of winning the tournament. Now, yes. Oh, gosh. Oh, yeah, yeah, absolutely. So if we're talking 1 in 64 chances, we're talking, you have a 1.6% chance of winning the NCAA tournament. Now, it differs because we know that there are some teams that are better than others,
There's upsets.
right? And there's upsets. There's lots of things that can happen, especially this year with COVID and testing and all that stuff. It's hard to predict what's actually going to happen. Okay? So, although, yes, we can say every team has an equal chance, they don't necessarily have an equal chance. Gonzaga was 31-0 going into last night's game, and they lost.
They would have been.
Right?
They would have been third team ever in the NCAA.
First team ever to go undefeated.
Right. So, you know, and then you've got, you know, like, okay, Cleveland State. Cleveland State, a big basketball powerhouse?
No.
No, not at all. But they made it to the tournament. They actually had the same chance of winning
As
as Gonzaga. And Gonzaga was 31-0 going into last night's game.
so did Ohio.
So did OU, absolutely. So, other things, the lottery is a probability, right? Okay, you pick 5 numbers and you try and win. So, we do use probability. Now, maybe not in our everyday lives, but there are some people who do, obviously with sports betting and things like that. Okay, so there's 2 different types of probability. Theoretical probability and experimental probability. Okay. So those are 2 types of probability. Theoretical probability is what should happen. This is what should happen when I pull a card out of the deck. Experimental probability is what actually happens when I perform an experiment. Okay? So theoretical, the root word for theoretical is theory. What should happen in theory? Experimental, what's the root word of experimental? So you're actually performing the experiment. So theoretical probability, again, is what should happen during an event. Cross products or compatible numbers can be used to determine the theoretical probability of an event. Okay? So we already did the probability of a red, right? What was our probability of flipping a red? 50-50, right? So probability of red is 1 out of 2. So every 2 times I flip a coin, I should get one of them should be red, correct? Okay. What if I perform that 20 times?
10, but you can't say that. It should be 10, but.
Right? So 1/2 is compatible. If I'm trying to figure out how many in 20 trials, do I know this?
Yes.
Do I know this?
No.
What would I put there? I'd put an X there. And then I could use what? Cross products or compatible numbers. 2 times 10 would give us 20, so 1 times 10 would give us. So we should get it 10 reds, correct?
Yeah.
What about the probability of rolling a 4 on a number cube? How many 4s are there in a number cube?
1.
How many possible outcomes are there?
6.
So we have what's our probability of rolling a 4?
1 out of 6.
1 out of 6. Very good. Okay. So the probability of rolling a 4 is 1 out of 6. What should happen in 42 trials? Okay. So again, setting up a proportion. Are 6 and 42 compatible? Brooks and Powski saying yes. How do you know they're compatible, Brooke?
Because 6 can be multiplied with
6 is a factor of 42, right?
Yep.
6 times
7.
7. If we didn't know that, could we use cross products?
Yes.
Absolutely. So x is equal to
7.
7. So what does that mean?
If you add 7 out of 43 tries, you should be.
Okay, 7 out of 42 trials should be a 4. heart? How many hearts are there?
4. No, 13. Oh wait, no, yeah.
There's 13 hearts, right? 2 of hearts, 3 of hearts, 4 of hearts, 5 of hearts, 6 of hearts, 7 of hearts, 8 of hearts, 9 of hearts, 10 of hearts. Jack of hearts, Queen of hearts, King of hearts, Ace of hearts. So there's 13 hearts. Okay. So what's the probability of drawing a heart? 13 out of 13 out of 52. So if I wanted to know what would happen in 70 or 78 trials, are 52 and 78 compatible numbers? No. Okay? Because even if I multiply 52 times 2, I'm getting 104. Okay? So how would I solve this? Cross products. Okay? So 52 times x. Okay. And then 13 times 78. So that means, does that mean I have a 52 out of 1,014 probability of getting a heart? No. I need to solve for x. So 52 multiplied by x, what do I need to do? I didn't. I didn't. $19.5?
Yep.
Okay. How would I say this though? Can you get a half of a time? No. So what do you think we would say?
Round it up to be 20. About 20.
Okay. In this situation, I would say you will pull a heart 19 or 20 times, right? Because with probability, are we really rounding?
No.
Yeah, no, we probably shouldn't round for probability. Do you think the lottery rounds?
No.
Ooh, you got 4 out of the 5, so we'll give you the money. No, they go, haha, sucker, you paid all that money and you didn't get anything, right?
Yeah.
So we can, even if our numbers are not compatible, we can use cross products to help figure out what our chances are. So out of 78 trials, 19 or 20 times we should get a heart. What's actually going to happen? We don't know. We have no idea what's actually going to happen. And that's experimental probability. Okay? So experimental probability is what happens when you actually perform an experiment. Experimental probability is the ratio of favorable outcomes to the number of trials. So what you want to happen versus how many times you tried to make it happen. Okay? So the probability of an event happening, when we're talking about experimental probability, is favorable outcomes over a number of trials. Back hurts today. It's getting a little heavy, I think. babes. What? I don't know if he's big. I'll find out next Monday if he's big. If I make it that one. All right, so experimental probability, rolling a 2. Are you ready? We're gonna do this 15 times. That's you. 15 times, ready? Okay, we got a 4.
3, 5,
Another 3. Yeah. Okay, so we're at 5.
6, 1, 4, 2, 1, 6.
11.
6, 5, 5, and 2.
Okay. Thank you, dear. This is what actually happened. What should have happened? No. Okay. Right? Okay, 6 and 15 aren't compatible numbers. So 6x is equal to 15. So 2 and a half? Right? Is that right? 2 and a half. Okay? So 2 and a half times we should have gotten a 2. Did that happen? It was pretty close. Right? Because the actual probability of rolling a 2 ended up being 2 out of 15. This is what should have happened. We should have gotten 2 and a half, but we got 2. Is that pretty close to our experimental? Is our experimental probability pretty close to our theoretical probability? Yeah, it's only half off, correct? And it's actually pretty accurate because you can't get a half when actually performing the experiment because you can't get half of a 2 and half of a 3, right? Now, what if we rolled the dice 75 times? Okay? Mace, you ready? I'm kidding, I would never. Okay? But could we predict what would happen if we rolled the dice 75 times? Yeah, we know that when we did the actual experiment, we got 2 out of 15. But we want to know about 75 trials. Are 15 and 75 compatible?
Yes.
If you didn't know what they were compatible, could you solve this anyway?
Yes.
What could you use if you didn't know they were compatible? Cross products. Okay. I know that 15 times 5 gives me 75. Right? Okay, so then 2 times 5 would give me 10. Okay? So you should expect to roll a 2 10 out of our keyword is expect, right? That's what we should expect to happen. Is that what's actually going to happen when Mason rolls the dice 75 times for me? No, it's not going to act that we don't know. It could. But that's the part of experiment. Okay? So we made a prediction. Now we could actually compare that to our experiment. Sound good?
Yeah.
Okay. So that's all, that's experimental probability and theoretical probability. It's all ratios. So it's all comparing your favorable outcomes to what you want to happen to what actually happens. Okay? Now, tonight for your practice, just the next page of the notes. Okay, so I think you have 1, 2, 3, there's 5 problems. Okay?